All right. How's it going? It's doing okay? So today we are going to talk about the Flint water crises. There's actually more than one, so I'll call it crises instead of crisis. So we'll talk about that. I also want to make a couple notes before we get into that. First of all, I did post some materials to our Moodle under the Flint water crisis section. There will be a Moodle quiz at some point. What I would like for you to do is obviously pay attention to today's, I guess it's kind of like a seminar in a way, more so than a lecture. But also take a look at these two papers here. I don't think you need to read super close into them, but I'm asking you to participate in the sense of reading the abstracts, browsing it to see if there's something that stands out to you as interesting, and read about their conclusions. Right? These are scientific journal articles, so they're going to be pretty, excuse me, pretty in-depth, and probably way into the weeds in terms of like the technicalities of what's going on. So unless you're specifically interested in that, don't concern yourself too much with that. But get a sense for what they're talking about and what they studied and why, and kind of the outcomes. So these are two papers published from one of the faculty that from Virginia Tech that really made a big effort in part of identifying the Flint water crisis and kind of just seeing what's really going on. So if you're curious about kind of his take on things, there's a lecture he gave, a link to that video there. So if this is something that's really interesting to you and you'd like to see more perspective on it and more about it, take a look there. So I will put a quiz up at some point for participation on that front. Otherwise, on Thursday this week, we will not have a live lecture. It's going to be in person only, so live meaning online. And this will be my PhD student will be giving a lecture on advanced oxidation topics. So taking disinfection further into what can we do on the chemical side of things if we use kind of smart ultraviolet technologies. Okay, and then that leaves next week for exam review and an exam. All right, so today I'd like to tell you about the Flint water crisis and where I found myself during this time as well. I actually had some pretty upfront and not quite personal, but almost personal experience with the ordeal. So we'll go through a timeline as kind of to tell the story in some sense, but just to take a quick look, we see Michigan here on this image. I was living in Lansing, and we'll see in 2014 I had moved to Lansing. I just got married. My wife was working in a 2-year fellowship position at the public health department there, and so she was involved with some things, including the Legionnaire's disease outbreaks, or involved with studying it and understanding what's going on. And then in 2015, I started working for Michigan's Department of Environmental Quality for a little bit of time. And thankfully, I was on the wastewater, not the drinking water side of things, so I was not in any way to blame for any of the issues. And then ultimately, I ended up getting a postdoc, deciding to go towards the academic route, and I was at Michigan State, which is technically East Lansing, if you ask anybody from up there. They're like, no, it's not Lansing, it's East Lansing. It's different, I promise. It's not all that different. So if you're from Michigan, you can hate me now. Okay, anyway, so what actually happened for the Flint water crisis? Really, it was several things at once, and at least you could say 2 crises. The first and most obvious one was the lead in drinking water. major problem, and was a kind of a terrible result, affecting lots of people, and doing permanent brain damage to many children, in addition to, as kind of one of the standout issues. Of course, it's not good for anybody, but it's especially damaging for children. At the same time, and for similar reasons, there was a Legionnaire's outbreak, so we'll talk about that. Legionella, or legionellosis, is essentially a bad case of pneumonia. It's naturally occurring, but our water system handling can induce outbreaks. A couple other things that were happening were there were cases where the city of Flint was not treating their water well enough, so they had high coliform counts in terms of bacteria in the water. So there were boil water advisories. Then they tried to chlorinate some more, and then ultimately they created a bunch of disinfection byproducts. So we talked about that recently. So high trihalomethane counts, and so they had to stop chlorinating so much. So they were really in a tough spot for that, and we'll talk about why. Okay, so I'm gonna go through kind of a bit of a timeline here, and what we'll see, I'm just gonna kind of walk through it step by step and discuss as we go. Okay, so the background. We used to use lead in our pipes pretty commonly. In fact, there's still a little bit that we do with galvanized metals, does incorporate a little bit of lead in the galvanization process. However, that's normally not an issue, possibly somewhat of an issue for groundwater systems that don't have the same corrosion control. But in general, the lead pipes themselves, just having lead there, means that there's potential for contamination. Now, if the pipe stayed intact and nothing ever happened to bring that lead off of the pipe, maybe we're okay. So we'll talk about why maybe it's all right that some places have lead in the pipes. But that's kind of the history, the context. We're going to start there. The next important piece to note is back in the 30s, 40s, and 50s, we had a very large auto industry boom. A lot of the Midwest, kind of northern Midwest areas, a lot of steel manufacturing, a lot of industry. And so for a lot of places, like Flint, Michigan, there was quite a great opportunity for people to make a living, for people to prosper, essentially, and for these manufacturing towns to grow, to have a thriving population, a lot of people employed. That kind of sets the stage then for when, for a variety of reasons, that industry collapsed. It's not that we don't make cars anymore or don't use cars. And so we could stop for a moment here and say, okay, well, this is the first kind of negative thing that's impacted Flint in particular, but a lot of similar regions. So as we think about Flint, what I'm not here to do is to say, exactly this is what's wrong with society and this is what we should have done. But we ought to reflect on perhaps things that played a role, right? And so whatever was happening that caused the auto industry collapse certainly led to a lot of problems. So maybe that was outsourcing a lot of the industry. Maybe that was regulations. Whatever aspect happened there, maybe that's too much or too little government involvement with the economics of it. I'm not here to say exactly, but that's kind of the context here. And this is what led to what you would call the Rust Belt, right? What we have, down in the South, the Bible Belt, and in the North, now we say the Rust Belt of this area where there was so much auto industry, so much steel industry, and now for many years, a lot of that was gutted and is not thriving as much as it used to. Okay, so that's a localized economic depression especially bad in Flint, Detroit, a lot of areas like that. And that's been the case since starting around in the 60s, right? That depressed the economy. And one thing that would do is people that could afford to find an opportunity elsewhere would attend towards going and finding opportunities elsewhere, right? So that you had a big population, and now suddenly, now that there's no more opportunity to make use of, a lot of people are going to move if they have the chance. So one impact there, and again, not speaking on what's right or wrong, but people that have enough opportunity on hand to take the opportunity to leave are going to. So you're left with a lot of people lacking opportunity, lacking resources, and in the middle of this kind of economically depressed circumstance. So it's really not a good situation, especially for anyone who's still there. You might imagine that the population probably, I think it was at least went to half, if not less. Might be 20% of what it used to be. And so that's, thinking about the tax revenue to just keep the roads paved, for example, or whatever local needs are present. That's a big deal, right? So now there's a bigger tax burden to try to keep the infrastructure that was designed or was put in for a large population. That's a major issue that regions like that face. So by year 2000, I guess the early 2000s, the state of Michigan in particular decided that, well, it's been like 30 to 40 years of trying to handle the situation, trying to help with the situation. And what they had been doing, and I don't know when this started, but they had been doing a revenue sharing from one city to the next. So if Grand Rapids, for example, was doing pretty well, some of their tax revenue would be shared with some of the cities that weren't doing so well, or might have been county, but I think this was cities. So for a long time they were doing revenue sharing, and you might think to yourself, well, that's fantastic, what a great way to help. But there is an important question there about, well, how long are you going to take money from some people that presumably they were expecting to pay and agreed to pay for their own infrastructure, their own needs in their city, and give that to somebody else, right? Is there a limit to that? Is there an appropriate amount? You could even watch your own thinking here. It could be easy to take this to one extreme or the other, to say, well, what's the limit? If it's good to do it some, why not do it all the way? And we go all the way to complete socialization of all these things, which is probably not the answer here, or at least you could say it's probably not the answer that the people that are being taxed want, right? So on the flip side, you might say, well, these people are obviously in a bad spot. Why are you going to suddenly take this away? Maybe we could do this gradually. Maybe we could set some sort of timeline, or maybe we could just keep it going, right? There's arguments for all sorts of pieces like that. But at the end of the day, it's an important issue to address, right? And charity, in some sense, this was a charity program, and as wonderful and as great as that is, there's some element where charity can't be infinite, right? It has to be charitable, and so if it's forced or obligated, so this created a big problem for these communities. Right or wrong, whatever the case, all I'm saying is that it's understandable that people wanted balance here, or a rebalance, right? That's really all I feel qualified to say. Is I'm understanding, I think, both the harm and the importance of making a decision like that. So in 2011, the state of Michigan began appointing emergency managers for Flint in particular, but I think several cities this was deemed necessary for, and this was because these cities, the municipalities, were getting very close on defaulting on their financial responsibilities. That means that they simply did not have enough money to pay for the things that they were spending for, right? So it'd be like having a credit card and you spend a lot of money on it, but you have no income to pay it off. Well, it comes due eventually, and what do you do about that? Well, you know, if the city is just sitting there defaulting on base infrastructure stuff, you know, what actually happens? That burden has to go somewhere, or maybe everything just shuts down. So neither of, you know, the shutting everything down is not tenable. That's going to cause a huge amount of harm. And so the state puts these emergency managers in place with the idea that, okay, well, somebody has to make the difficult decisions and stop paying for something, and the local municipality is not doing it, so we're going to appoint somebody to do that for them. Now, this, as we'll see, you know, ultimately was a very big mistake, or at least the implementation of it was a very big mistake. There's, again, maybe something to be said about having a way to create some kind of financial accountability or action there, but we'll see that appointing somebody that was not elected, that's not representing the people, making these types of decisions was a pretty terrible thing. Okay, and it really began in 2013. And by the way, these emergency managers would be kind of one-offs. It would be a yearly appointment, and the governor would appoint, you know, maybe his friend, maybe somebody he doesn't like, or I don't know who. Somebody, presumably with some business experience or something, to go and govern, essentially, to be an effective mayor for this situation. And so in 2013, whoever was emergency manager at the time decides that it was going to be a good idea to switch their water source, because Flint had been buying water from Detroit, and to switch that over to essentially get water from a, you know, if we flip back, well, I don't have it right now, but I have to go back through everything. I guess we'll do it. They wanted to get water instead of from Flint directly. They were thinking, well, maybe we can get it from Lake Huron. So take an intake there and pipe it through. And that was comboing with some plans. I think it might be Saginaw, if I'm not mistaken. Another municipality somewhere right here was going to construct some. And so it was a reasonable plan that could be implemented and perhaps was a good water supply, because as it was, they were feeling like Detroit getting their water and then shipping that water up was more costly than it should have been. So the emergency manager was thinking to themselves, like, hey, we're spending a lot on this Detroit water and sewerage water. Maybe we can save some money if we do this. And I think they wanted to save something like maybe $5 to $10 million over some amount of time, you know, maybe every 10 years or something. If they could make that switch and be sourcing the water from themselves. So the city of Flint had a small water treatment plant, and what they'd use it for typically was to touch up the water sent from Detroit. So Detroit would take in the water, treat it, send it up the pipe, and so Flint was typically then just recharging a little extra chlorine and sending it along through their system. So that was the typical practice there. But you know, the emergency manager made that decision, and then well, the Detroit Water and Sewerage Department was a bit upset when they heard that, and apparently gave them a 1-year notice of, okay, well, if you don't want to buy our water anymore, why don't you just tell us? Like, it feels like there was some drama there or something, because they gave them a 1-year notice of termination. And so here you could rightly I think, fault this decision on Detroit Water and Sewerage Department's decision making, because that put Flint in a pretty difficult spot, in that they no longer had the amount of time that they thought they would to implement their new project. We'll see later that perhaps they redeemed themselves a bit, but this was also a pivotal moment that really caused Flint, Michigan to say, oh, well, now maybe we don't have quite enough time for these renovations. So then they decide to switch, more rapidly to the Flint River. The Flint River does go through, Flint, obviously, but obvious by the name. But it was not their planned source. And an important local note is that a lot of the residents would certainly associate the Flint River with toxic dump sites and nastiness, because that's kind of been the history around the area. And while the surface water itself would probably be okay, you would need to be careful if the sediments from the Flint River were disturbed. So there'd be a lot of monitoring and checking that probably ought to go on for that. Okay, so by April 2014, Flint, makes that decision, and the real issue here is, as we will see, it turns out the Flint River is more corrosive naturally. So the natural elements in it, the minerals, it just happens to be more corrosive. Maybe it's a lower pH, maybe it's just a lack of alkalinity. It's more corrosive, and the big deal here is that we have to control for corrosion if we want our pipes to not corrode, right? So if we have more corrosive water, it's going to tend to corrode the pipes if we cross some threshold. And that's actually, we can look in the chemistry of it all. We would call it the geochemistry. At what point, what conditions does something dissolve versus precipitate? We actually talked a little bit about these equilibrium reactions, if you recall. There's an equilibrium between the solid, metal, mineral, whatever it is, and the dissolved phase, right? That's going to be dependent on things like pH, on temperature, and the corrosivity, essentially, the oxidation reduction potential of the water. So has to do with the natural chemistry there. And normally what we will do is operate in a way where we want the opposite of corrosion to happen. So rather than letting a pipe corrode until it breaks and water gets in from outside, or water's leaking out, rather than have that problem, we would rather have the problem, because it kind of goes in one direction or the other. We'd rather have the problem where minerals slowly are depositing. Now, we don't want like fast, huge mineral deposits to constrict our pipes like in a decade. What we want is, over the course of 100 years, maybe a pipe's going to get so coated with the mineral deposits that eventually we'd have to dig that up and replace it. That's a much better outcome than having it break. So by design, we normally have this anti-corrosion, in a sense, this precipitation type of dynamic for our piping systems. So when we introduce corrosive water to pipes that have lead, suddenly we're eroding away on the pipes or the mineral deposits on them. Now we get a point where we're starting to allow lead and maybe even just particulate matter that contains lead into the water stream, sending it down the pipes. So this is really, we'll call the start of the Flint water crisis. As soon as that is happening, as soon as they implement that and they fail to add corrosion control, because it's not hard to add corrosion control. It's something that was an oversight by whoever was working in DEQ, whoever was working at the facility and reviewing the necessary protocols. This is a major, major failure. It sounds kind of like a small thing, and if you notice, we talked for 3 months now almost about water treatment, and we didn't really talk too much about it directly. So it's not a major component in our minds necessarily, but it's a major component of maintaining the distribution system. And really, we would call it orthophosphate, which is just phosphate, 3 minus. Some form of phosphate would buffer the water and help prevent corrosion, and it doesn't take a lot. So it's a very simple, simple solution to apply corrosion control. And so that's a real big issue that it wasn't there. Okay, so as soon as this happened, and by the way, just my own timeline here, I was still completing my grad school in Atlanta at this time, so I was not in Michigan yet. But as soon as that change happened, the Flint residents immediately started complaining about the water quality. It was immediately apparent to them that something had happened. Something changed with their water. It didn't look so good. It didn't taste so good. Now, the tricky thing here, as we talked about, is aesthetic concerns are not necessarily enforceable, right? So if it's just aesthetic, then that might just mean the water doesn't taste as good. That can happen. Clearly, there was more to it than that. By August 2014, that I was technically finished with my program in August 2014, my PhD. They were having high coliforms, meaning this was kind of the height of the summer in Michigan. They had more bacteria in the water, and that means as they were treating the water, they were not treating it well enough. So they had to issue 2 different boil water advisories. And that's it's kind of understandable, but unfortunate if there's a boil water advisory for like a water main break or something. But when a facility is having boil water advisories because they're not treating it well enough, that's bad news, right? Something is really going wrong with the actual treatment. And it is overall pretty rare. So this was really not so good. That means they did not have enough treatment capacity to chlorinate in the way that they were supposed to and have enough contact time, right? So they probably didn't have enough big enough reactor, essentially, to do the treatment that they were actually required to do. So what did they do? They ramped up the chlorine, right? So they added more chlorine. And by the way, chlorine is corrosive, right? So they're increasing the corrosivity of their water, potentially. And then with this excess chlorine, they're getting lots of disinfection byproducts. So then now they're ping-ponging between not disinfecting enough and creating disinfection byproducts because they disinfected with too much chlorine. So they're having a real bad time because their plant is not designed properly. So another aspect here, so they missed the corrosion control, and they probably should have never even claimed that this was adequate treatment because it was not quite adequate, right? Their facilities were not, we'll say not large enough capacity, or I think it was the contactor that was the deal. So that puts them in a really tough spot. They kind of eventually sorted out at least enough to get back into towards the fall and then winter months where they weren't going to have so many coliforms. Meanwhile, they were telling the residents, hey, the water is safe. Well, I guess outside of the boil water advisory and outside of the times where they have the trihalomethanes, maybe they're okay to say that. It seems a little bit like a straight up lie to say it's safe during the water advisory, the boil water advisory, and the trihalomethanes. I guess once they fix those problems, maybe that would be okay. But then you notice what they're actually doing, and it's like, wow, that's crazy. How dare you? The local city officials were getting truckloads of bottled water delivered to their office so they didn't have to drink the water, while they were saying, hey, the water is safe. So it was pretty clear, clearly some problems, clearly a lot of hypocrisy. And the reason they might say, hey, the water is safe, to give them the tiny bit of benefit of the doubt here, is it may be coming out of the treatment plant safe. And under normal circumstances, you would assume that if it's coming out there safe, then it's safe when it comes out the tap, right? What they're missing there with their measurements, because there's no lead in the coming from the treatment plant, right? The lead's not coming from the Flint River. So they might be fine outside of the boiled water advisory, outside the trihalomethanes and stuff. Given that those are taken care of, saying that the water is safe kind of makes some sense. Clearly, it was the wrong call because it was not safe. Okay, by December 2014, the upgrades required to get the chlorination and trihalomethanes and stuff taken care of, they had already spent $4 million on the water treatment plant. And their whole plan was to save maybe $5 million over the course of a few years, something like that, by switching. So they'd pretty much already spent most, if not all, of the money that they were hoping to save. And this is just less than a year after making this change. And this is not even the final solution that they were aiming for with taking water from Lake Huron. Okay, so very, very much in a bad spot. And it might have even been less money than that saved. I'll have to go back and take a look at the numbers. Let me, real quick, by the way, it was October 2014 when I moved to Michigan. So water crisis was in full force. People didn't quite know the extent of it at this point. But people were very aware that there's a big problem. And the residents were very unhappy, even though they didn't know they were being poisoned. They just kind of assumed it at this point. And they, that in that case, that was the right assumption. So by January 2015, Detroit Water and Sewerage Department kind of sees what's going on, and they make a good offer, a very generous offer actually. They offer to reconnect to the Flint system and waive the fee. Now that might just sound like, oh, how nice, all right, you don't have to pay the $100 to file the paperwork or whatever. No, this is a fee, a multi-million-dollar fee probably, or at least hundreds of thousands of dollars, because this is the engineering costs, right? To plan, to draw, to set up, to excavate. This is a big fee, right? So this is not a small thing. This is a big offer in terms of the amount of money that would be required for all of that. So that's significant, and that Detroit Water and Sewerage Board, potentially redeeming themselves a little bit here. However, the emergency manager decides to reject that because he's stuck in his mistakes. It's also possible that they had a new emergency manager, because they were changed yearly. Sometimes they'd have the same one for several years, but if you go and look through the timeline, it kind of bounces around a bit. By March 2015, the City Council votes unanimously to reconnect, to accept that offer. They want to, but the situation of the emergency manager having the authority there, able to veto it, kind of shows why we don't like tyranny, right? We don't like that top-down type of structure of governance. The people recognized they needed this change, and knew much better than this emergency manager, who's probably not even living in Flint, probably living in Lansing or somewhere. That he rejected it despite the unanimous vote. And it wasn't until kind of May, June time time frame, the middle of 2015, where pediatricians were starting to notice elevated levels of blood in children. That's how the real essence of the Flint water crisis, at least in terms of lead, was discovered. So there was a particular pediatrician. She was really trying to contact different people to figure out who could assess the water. How could that be done? She came across Mark Edwards, who's a professor at Virginia Tech. He had worked with kind of a similar corrosion issue in the DC water system some years before this, and so got in touch with him. He and his students, his research team, ultimately were able to provide the right methods to test the water and to see what was going on, and were instrumental in identifying and revealing that, yeah, there's some bad stuff here. His lecture, by the way, is very interesting. He has some very harsh things to say about the EPA's involvement in this, or lack of involvement in some cases, that the EPA apparently had not acted properly in some cases where they should have listened and should have taken some things seriously here, and failed to do so. So if you want that angle on it, take a listen to his lecture. Okay, by October 2015, Flint decides finally to switch back to the Detroit Water and Sewerage Department. That means that now they're getting corrosion control back into their water, and their water is no longer going to be actively corroding the lead pipes. So this will not instantly, but nearly so, stop the Flint water crisis. At least the end of lead corrosion. By the way, lead, we have the acronym, or the lettering PB for lead on our periodic table. That's what it, those are the letters, and it's actually comes from the Latin word the same Latin word we use for plumber. The PB in plumber is coming from that, and that's because in Roman days they did most of their plumbing with lead. So what they used for much of their pipes was lead, because it was pretty abundant and malleable, easy to work with and create into a pipe that could seal and make sealed connections. So there's some potential debate about if lead poisoning was an issue in the demise of the Roman Empire. In fact, maybe they didn't have corrosion control. Could be as pretty simple as that, right? It could be a change in their water supply causing corrosion. Could have made a big impact. Okay, so anyway, they switch back. Now, almost immediately, well, for sure immediately, the water is now going to stop corroding the pipes. Now, there may be some scenarios where the pipes had corroded to the point where there's still flakes of metal or flakes of things that would be coming off, and it would take a little time before mineral deposits started coming back onto it. What we've seen in the past 8 years since then is there's been a massive effort to just dig up all the pipes, to clear them out, and to install lead-free pipes, and to just get rid of the issue altogether. In a way, that's a little bit of a wasted effort on the technical side. I don't think it's wasted effort on the social side and the feeling of the situation. Like, how dare you leave lead pipes here when you've just done this? Like, there's probably some attitude like that, and probably a lot of comfort that people would take in knowing that can't happen again because there's no more lead in the water or in the pipes. However, from a technical perspective, we have lead pipes in a lot of places, and as long as we're operating properly, it shouldn't be a problem, right? So theoretically, we could have. That didn't have to be the technical solution to the problem. I think it would make sense not to add lead in our pipes anymore, just as a precaution. And I don't think we tend to make them only out of lead, for sure. Okay, in January 2016, the governor at that point admits there's this Legionnaire's disease outbreak. That had actually been ongoing from the summer of 2014 and 2015. So this is a separate aspect. Hadn't mentioned yet. We'll have a few slides on that. We'll talk more about it. But it was kind of retrospectively, they had been hush-hushing it because of all this other controversy going on. But the Legionnaires outbreak actually killed people. So if you didn't hear about that, the lead poisoned people. I don't think there were any deaths associated with that, although that probably does shorten the life expectancy and life quality, if nothing else. But there were some, people that were probably immunocompromised in the hospital. There was a couple hospitals particularly affected, but deaths associated with that. So the one thing you might not have heard is the Flint water crisis had also essentially caused death, according, given this outbreak. Yeah.
So how did the lead cause the outbreak of?
It's a great question. So the lead itself didn't cause this outbreak. I'll elaborate for a moment right now, but I'll talk a lot more about the Legionnaires outbreak in a couple minutes. Essentially, the Legionnaires bacteria, Legionella, probably a couple of different species, but it's a bacteria that's naturally occurring in a lot of water bodies. It's also named Pontiac fever. It just happens to be pretty prevalent in Michigan, but it's kind of everywhere. But it's the Pontiac fever or Legionnaire's disease. It's typically you only get it if you're inhaling water that has a lot of the bacteria in it. So the reason it's called Legionnaires is like there was maybe in the 50s or 60s, the Legionnaires was a club or some sort of activity. They happened to be exposed to the same contaminated water source. They all got sick, and so they named it that way. It's typically not transmissible from one person to another, but if your water supply has a lot of it, and then you take a shower, for example, and the spray, and you inhale that, that's the type of transmission of it. So the deal with the switching of the river supply is, you might be introducing more of the bacteria in the first place. The issues with treating it was another issue. And then there's another aspect of just that big of a change of water chemistry in the pipes. And the fact that, again, kind of looking all the way back to the fact that we don't have many people living here compared to what the infrastructure was designed for. There's actually a lot of empty homes and dead zones in the distribution system. So if you have a neighborhood that has like 2 occupied homes out of 50, there's going to be a lot of stagnant water there. So there's like stagnant water, there's a change in the water, there's a lot of aspects that kind of feed into the reason why we might have this outbreak. It wasn't directly associated with the lead by any means, but the opportunities arose from for similar reasons.
Is Flint still like unoccupied?
I think economically, like population-wise, I think it's still very much lower occupied than what it was in the 50s, right? So it would be, Baton Rouge had a doubling of population back in 2005. If you were to just imagine that in reverse, like half or more people leave, there was a lot of, I've heard there's a lot of changes in traffic patterns here, and people still kind of, complain about that today or whatever, just how much more traffic there is. Kind of the inverse would happen, right? And I think it's still, today, there's a lot of vacant homes, a lot of vacant lots. And part of the challenge, even with the changing the lead pipes, has been we don't actually know, we don't have blueprints to tell us where exactly the pipes are in a lot of cases. So it's a big project. Okay, so we'll talk more about the Legionnaires in a moment. So from then on, the legal outfall has continued. There might have been some small updates in 2022. I think I saw something in the news recently that they're just about done with all the lead pipe removal and exchange. So at first they were not sure they could even do it. And then they I think got the help of some AI systems or machine learning systems that could help identify probable location for pipes and which ones are lead and which ones are whatever. So a lot of money went into exchanging that. Some of the legal outfalls, so by January 2021, the former governor, Rick Snyder, 8 other officials charged with 30 felony counts, 2 misdemeanors, 2 officials were charged with involuntary manslaughter. Now these are charges, these are not necessarily the sentencing or anything like that, but one thing you'll notice when I talk about the Legionnaires outbreak is it's hard to say if we get these things right. It's good to see, there should be, in this case, legal action because there were some very bad behavior leading to extremely bad outcomes, right? So as far as I understand, the legal outfall, is continuing. There's probably mostly resolved by now. But yeah, so it was a pretty big deal. So to kind of sum it up a little bit here, what were the failures? The lack of corrosion control was the major one, right? We see this picture on the right over here, the left of the two, that's the tap water during the Flint water crisis, and then on the right is the tap water in 2016, shortly after they changed to the Detroit Water and Sewerage. I guess that might be a year after. So here they note they have at least 3 parts per million of phosphate, so 3 milligrams per liter. No Legionnaires, a little bit of lead, no Legionnaires detected. In October 2015, while the Flint River was still being used, there was no phosphate. They had more iron observed and quite a few gene copies of the different Legionella bacteria observed. So that's just one caption from those papers that I put up there for you. Okay, so then another operational operational failure was just simply the inadequate treatment capacity at the Flint River plant. They should have never authorized it to treat the water, just given the disinfection capacity. They should have required upgrades first, expansions to prevent that. So 2 major design failures at the scale of the treatment plant. They didn't add corrosion control, which is, by the way, a very simple thing to add. That's not a complex issue. Led to excessive chlorination, and on the flip side, failures to disinfect. Simply having that corrosive water supply, and then that aspect of many vacant homes, right, was also an issue, because at that point, if you have something corrosive and it just sits there for a long time, that can kind of have a worse effect than if you had water flowing through. Even if both cases are bad because it's corroding, that aspect of just stagnant, I think that can cause more problems in that process. That also has to do with the Legionnaire's disease, having more Legionella in there. Okay, so let's talk a little bit about this Legionellosis. So these are some slides that my wife presented way back while she was there. So Legionellosis is a bacteria. It can give you pneumonia. It could be a bad case. Most people, if you're healthy, it's probably not a terrible thing. It's pneumonia. It's actually not transmitted person to person, or very, very rarely. I think for whatever reason, it's only known to be a water system. Could be like a cooling water tower. If you have water that has a bunch of that bacteria in it, you'll probably have walked by our cooling tower on campus. It's a little bit misty spray sometimes. That kind of thing, if you're working around it and it has this pathogen everywhere, maybe that could give it to you. So, hopefully that's clean. It's not a huge risk, but that's the type of exposure. shower water that's got aerosolized spray with a lot of the bacteria, breathing that in, that would give it. So, okay, well, how do we track a disease? And I think we all learned a little more about this with COVID, or the failures there. It's kind of silly to try to track COVID for a few reasons, but let's talk about Legionella for a moment. Normally, you'd get exposed to it, some pathogen, you'd get sick by the pathogen, you go to the doctor or the hospital, and they say, okay, you've got this particular disease. Once we identify it, that means we actually have to report that disease. If it's, if it's the common cold, then they don't report that anywhere. If it's the flu, they don't report that anywhere. If it's a particular reportable disease, then it triggers a process where they say, oh, okay, we're going to send that information. Usually they'll probably get it lab tested, would be the first thing. Maybe they have a test on hand that can do it. So in some way or another, that information is going to be ultimately transmitted to a state surveillance system, probably also to a local health department, and that will be in communication with the state surveillance. But one way or the other, it gets caught by a surveillance system. Now, in the case of Flint, they actually knew there were many, given the system that Legionella is surveilled in Michigan. And so they actually knew in 2014 they had a lot of cases in the summer, more so than normal. And we'll see some data in a moment. And again in 2015 in the summer. The issue was there was a breakdown where the local health department really was not doing what it should have done. So as essentially an intern, a little more advanced than an intern, but a fellow, I guess, my wife actually was working at the state and trying to get them to complete their surveys properly to survey the people getting sick, and to take specimen samples to get a DNA match to know where this is coming from. So the health department had a major failure there because they refused to match or even collect DNA samples. The state health department was telling them, hey, you need to do this. Hey, you need to do this. Please do this. And they just were refusing to do it. And there was so much distrust, and have a little bit of sympathy for that. There was so much distrust from the local health department to the state that they were trying to, and by the way, this could then also go into the CDC. They were trying to bypass any conversations with the State Department and talk directly to the CDC, which is silly and foolish, and the CDC is just going to say, no, go talk to these people that have been authorized to do this program with you, over you. So there was some major breakdowns there on a personnel or like people not doing their jobs, right? At the same time, the State Department, when they recognized, hey, there's these two hospitals that are a big problem. There's a lot of illnesses at these two hospitals. Let's take a look. Let's investigate a little closer. Oh, we think it's this McLaren hospital. But the higher-ups in MDHHS were telling the people that knew, like my wife, not to say anything, not to name the names, and it turns out that was because, what else? Corruption, right? There was somebody higher up at MDHHS that had a connection with one of the executives at that hospital. And so, of course, there was issues there, and so it took a long time before that was revealed. I think in the past 3 or 4 years it was revealed, whereas we kind of knew back in 2015 that there was an issue with that particular hospital. So let's take a look at a bit of the data. Typical Legionnaire's cases like I told you, it's kind of endemic. It happens in the summer. Typically, you have a case or two per month in the summer months. So you see like kind of typical, okay, occasionally three cases in a month, 1 to 3, oh, there's 4. And then we change to the Flint water supply right here, right? That's the Flint water crisis. Let's say Flint water there. And suddenly, boom, right? Now we're getting 10 cases in a month, 8 cases, 6 cases, lots and lots of cases comparatively. So that's pretty obvious that now we have an outbreak, and we're even getting some in the winter months, which is, if you were to check these other years, it's pretty rare. It's sometimes maybe a little bit, but we really have that big spike there. And in 2015, we had another spike. So if we were to get that data, it looked something similar. Okay, so that we had 2 clear peaks both summers that we had the Flint River water. And we can take a bit of a closer look. Here we see 2 hospitals in particular they're concerned with, because if a hospital system, it kind of handles its own water, has a water handling system, and if they're not operating their in-house system correctly, they could have some issue there. And turns out that's probably what happened. So we have Hospital A, and those are highlighted in red, and that's McLaren Hospital. And then we have blue, residents on Flint water, and then blue, like that, and then the gray is neither. Okay, so the questions are, where is this coming from? Is it the Flint water? Is it the hospital? Is it the hospital because of the Flint water? So epidemiology is very much about trying to figure out, trying to show or track where the disease is coming from so we can know something about how to stop it, right? Okay, so here is the data with the second peak, right? So if we take a look at this, there's a couple things that could happen, right? You could get the sickness and then go to the hospital because of it, but I think these cases are primarily talking about patients who were already at the hospital who became ill with it. So that's what I'm referring to when I say hospital exposure. Or maybe they were discharged from the hospital and then got sick with it. So they were, it's quite possible that the hospital made them sick, right? Okay, so we see these outbreaks and we see how much of these are explainable. This Flint River water exposure is partly explainable, perhaps, but a lot of this seems to be just that hospital exposure. Now, one thing we see over here on this upper right, they have moments where they attempted to treat their water, treat their water system at the hospital. So the arrows here, I think I might have another slide on that. Yeah. Kind of another picture of just this here. It's just on a different graph. These little lines I'm going to highlight, the little arrows here. So what they were doing, if we look back in that August, so this is 2014, 2015, and then 2016. So at these moments, they added a lot of chlorine in the hospital system to try to treat it. So they added a lot, helped a little bit, but it came right back. They added a lot, didn't even really help too much. And these are the percent of the samples they collected were positive with bacteria. That's kind of what we're showing on the graph here. And then they say, okay, well, that's not good enough, so let's do super hot water plus chlorine. That finally, once they did that, seemed to be helpful, and then they installed monochloramine units to keep up a residual chloramine as a kind of a slow-acting disinfectant. Okay, so it took a while. The hospital basically was, not taking it seriously. They should have had some of this in place and should have done this sooner, but eventually they did it. Okay, so here's a bit of data on what portion of these. I think the data we just looked at a minute ago is actually a little easier to see, but you can break it down by the numbers here. Okay, how many people were using City of Flint water versus the township water, which may have been different, or some other water, maybe they don't know, or a private well. So you see we have exposures for most of these, there are exposures. And then there's some question about, okay, well, what about hospital or healthcare exposure? And at the end of the day, there were people getting sick with or without Flint water directly, and with or without the hospital directly. So it's very likely that the Flint water was part of the cause, and the hospital that had been filled with this Flint water was also part of the cause. Right? So there's two things happening there, coming out in that. Okay, so a bit more data here, and ultimately McLaren Hospital was finally found to be at fault. And the deal is, I showed you all this stuff. This was happening in 2014 and 2015. The health department was pretty much aware of it, but hushed by corruption. And so when back in our timeline, if we go all the way back here, it wasn't until February 2017 that the linkage was actually formalized. The CDC was finally able to get, I guess, maybe old samples of the Legionnaires' outbreak or something to DNA match it. Way, way, way further down the timeline than it should have been. Like that should have been happening in 2014 to say, oh, we've got this Legionnaire's disease. Here's the DNA. Let's check it with the water. Oh, the water's got some. That should have happened years ago, right before this. So that just took a lot longer than it should have. All right. I think that's about all I have for you. So any questions? Find that interesting? Hopefully. All right. So, yeah. Yeah, I'm not exactly sure what everybody got in terms of like who was charged and everything. I probably ought to dig into that. Wikipedia has some info.
At what point, I guess it's all documents. I don't understand how the officials would just they're not really saving that much money. So
Right.
Why is it?
Yeah, it was such a foolish thing for the emergency manager to do, right? It was to think that bit of money to save would be reasonable.
It's like that yellow, how would they?
Well, that wasn't coming out of the plant, that yellow. That was coming out of the taps, that yellow. So could have been that. It could have just been, the most charitable you could say would be ignorance, and laziness or something. But that's a big problem with the emergency manager, right?
So who's responsible for the pipes? Like I know we're saying that it's not coming out of the plant, but you can see that it is coming out of the pipes.
That's a very good question, and I'm going to answer this question for you guys real quick because I should have included this in here. There's what's called the lead and copper rule that's supposed to monitor at random in pipes, like at the tap. That has been revised in response to this, so it's been updated so to hopefully catch this kind of thing better. So it is still on like the water distribution, the EPA's, and thereby the DEQ, but that had to be revised because it just wasn't doing the job well enough here.
What happened to the kids that were affected?
Lead poisoning is, I think, lifelong impact. So it tends to have a severe impact on IQ, and I don't know if there's probably some sort of legal or financial things. Yeah, you guys are free to go. I'm going to answer any more questions. Yeah, so I don't know exactly, but it's terrible. Yeah. Mm-hmm.